Okay, so today's lesson is on literal equations, and actually should have taught this along with 1.4, which was solving regular equations, because really the only difference in the notes is we're going to have multiple variables, and I'll have to tell you what to actually solve for. So let's go ahead and get started. We've been seeing literal equations for a long time now. We just haven't called them literal equations. We basically called them formulas. All your formulas from geometry and algebra 1 and all pre-algebra, those are all literal equations. They had more than one variable going on. We just called them formulas instead of literal equations. Whereas here, I asked you to solve for v. Well, maybe I could take this whole equation and say, hey, let's solve for w. Or in this one over here where we have the slope-intercept form of a line, maybe I have you solve for slope and get the m by itself. That's what we do in literal equations. So let's go ahead and look at our notes from here on out. As you can see, it's basically the same notes that we had for solving equations. Actually, you don't even have to read through these. It's the same stuff. We simplify each side of the equation by getting rid of parentheses and combining like terms. Ask ourselves the questions, how many variables do we have? More than one is bad, one is good, so on and so forth. Just go through those same questions the same way that you solved it before. Here we just have a whole bunch of your formulas from geometry just to show you that, yes, we had letters all over the place. Perimeter had letters all over, area had letters all over, and we're just going to solve for different variables instead of our areas and our perimeters and our such and so forth. So let's go ahead and get started. Let's do some examples. Okay, I want to do this example twice. The first time we're going to solve for h. And I'm going to do it wrong a couple times so you can see some of the ways that people do it incorrectly. So when I solve for h, I want to get this guy right here by himself. So we have to move the pi and the r squared. Some people want to do this one step at a time, and that's totally okay, but it's going to look weird because if I divide both sides by pi, that's great. I'm going to get a over pi equals r squared h, and then they think they got to divide by r squared, and then we get this thing called a complex fraction. We never want to have a complex fraction, but watch this craziness. Let me erase that. If I'm dividing both sides by r squared, I already have a division bar right there. So I don't have to add another division bar. I can just go ahead and put r squared in the bottom, and look at that. We got h equals a over pi r squared, and we have our answer right there. Okay, so let's go ahead and erase this, and we're going to solve for r this time. A lot of it's going to be the same stuff. I'm going to divide, but in this case, I'm going to tell you what one of my students today said. Well, what if I divided both sides by pi r h? And I'm like, well, we are thinking really well here. I do like the thought process because that gives us an r all by itself, and this is what it looks like on the other side. And I get this kind of answer a lot in Algebra 2 Honors, where I have an r or whatever letter, and then I have another one of those letters on the other side. That is no good, all right? So we cannot solve for a variable and end up having that same variable on both sides of the equation. Remember, if you have more than one, that's bad. So when you ask yourself the questions here, what are we solving for? R. How many are there? 1, 2. That's bad. So let's come up with a different way to do this one. So let's erase all this stuff and start again. The process was good. Division has to go first. I'm going to get rid of the pi and the h by putting them over here. So I have r squared equals area over pi h. And the way we get rid of squared, the inverse of square is square root. The inverse of exponents is radicals. So we're going to take the square root of this side and the square root of this side. I'm not going to spend too much time because there are some issues with having a fraction under a square root. That's a later lesson, so I'm not expecting you to know that yet. But I do want you to know this part. And I'm going to say this about 1,000 times this year in class. You guys won't be here to hear it, but I'm going to say this a lot. When you square root both sides of an equation, On one side of the equation, the square and the square root cancel out. The other side gets a plus or minus. So we put a plus or minus in front of the square root, and then we leave it like this. This is not simplified, but seeing as how it's a later lesson, I'm going to go ahead and let you leave it just like that. All right? Here we have another example, and I want to do it a couple of different ways. The first way is getting rid of the fraction first. I'm moving the 5/9 to the other side. Now, I had somebody today say that they should divide both sides by 5/9, which is a good idea, except for when you divide c by 5/9, it looks like that. And that's that fraction in a fraction again. We don't want that. So let's go ahead and erase that. If you remember the keep, change, flip, then it would make more sense. We never divide by a fraction. We multiply by its reciprocal. So it looks like this, all right? So I multiply both sides by 9/5, and that gets rid of the fraction on the right. We still end up having a fraction on the left, but that's okay. The parentheses are now gone, so I can move that 32 over by addition, and I'm left with this answer, all right? And then if you want to rewrite it with the f first, there you go. And if you notice that, that's the formula for turning Fahrenheit to Kelvin and Kelvin to Fahrenheit. I want to show a different way to do this. So let's come back up to this part right here, and let's do it a different way. So I'm going to rewrite it because I hate having that fraction on the back end. So I'm going to rewrite it like this, and I'm going to go, well, I'm not a big fan of fractions, but seeing how there is one term on this side and one term on this side, if I multiply all my terms by the same number, I keep the equation balanced, and I can get rid of this 9 in the denominator. So if I multiply this side by 9 and this side by 9, I can cross that fraction out. And that gives me 9c equals 5f minus 32. Now, I guess you could divide both sides by 5, but then we're going to be right back over onto this side like we already did it. So I'm going to distribute the 5. That way I'm staying away from fractions as long as I can. And now it's a simple two-step equation where all I have to do is add 160 and then divide by 5, and I got the f by itself. But this answer looks totally different than this answer. But it's not really different. It's two different ways to write the same equation. It's like me saying I got 3/5 and I write 30 over 50. They are equal even though they look different. These are equal even though they look different. This one is written as 2 terms. This is written as 1, but they are the same. Okay? So either way you want to do it is fine by me. All right, so here's one of the harder problems to do. And first thing I want to point out is I hate using this x as a multiplication sign. We will just use a dot, all right, or nothing at all. You can just push the r and the h together. So we follow the rules of solving, and that first rule is to simplify both sides of the equation. So the left side needs to be distributed. Capital R h plus r squared h equals capital R, capital H. So, also, I didn't tell you what we need to solve for. I want you to solve for capital R. All right? So, now that it's simplified, I'm going to ask myself the 3 questions. What are we solving for? Capital R. How many are there? 2. That's bad. Are they like terms? No, that's worse. We went from bad to worse. When we go from bad to worse, we're going to have to factor at some point. So let's go ahead and get our capital R's on the same side. So I'm going to take this capital RH and move it over to the other side by changing its sign. So I have R squared H equals capital R, capital H, minus capital R, H. I still have 2 capital R's. That's still bad. And I can't put them together. That's still worse. So I'm going to factor. Factor is undistributing or unfoiling. If foiling and distributing is a multiplication, then unfoiling or undistributing is division. So I'm going to divide out a capital R, and that's going to leave me with a capital H and a little h. Now look how many capital R's I have. Just 1. 1 is good. Now I can get rid of that parenthesis. I don't even care what's in the parenthesis. I can get rid of the parenthesis by division. And I'm left with capital R equals R squared H over H, capital H minus little h. And I don't care if you put the parentheses down there, as long as you're not going to go ahead and cross out those little h's. Don't do that. And there's my answer. We're going to do one more example here, so hold on a second. So here's an example that a lot of kids just quit on right off the bat because too many letters, too many fractions, and we don't want to do it. We got to get past the part where fractions are the enemy, all right? So especially when there's an equal sign, the equal sign is a great friend to us because it's going to help us get rid of those fractions. What we have to do is figure out the least common denominator. That's important. So A, B, C. What's the first thing that A, B, and C can go into? I have no idea. When you don't have any idea, just multiply them all together. Hey, there's the least common denominator. Multiply each numerator by A, B, C, A, B, C, A, B, C. And then physically cross out the denominator with whatever it could cross out in the numerator. All right? And when I'm done here, you'll see that there are no more denominators. So I don't have any more fractions. Just write down what's left. B, C. Oh, that's not an equal sign. Let's back up a little bit. Plus AC equals AB. If you haven't noticed yet, I forgot to tell you what to solve for. Let's go ahead and solve for C. Solve for C. I did that because we're going to save a step because the C's are on the same side. I could have solved for B. I could solve for A. Doesn't matter. So I don't have to simplify anything. There's no parentheses. There's no like terms. So ask yourself the questions. What are we solving for? C. How many are there? 2. That's bad. Are they like terms? No, that's worse. So we're going to have to factor. So let's go ahead and take this C out. What's left when you divide it out? You have a B plus A equals AB. And now it's one term and one term, so I can just divide. Remember, you can get rid of factors by division. B plus A. I don't know why I wrote it so small. B plus A. And then I have my answer is C equals AB over B plus A. And that is the answer. Now, I put a homework on Canvas, and there's like 44 questions on there. I don't expect you to do all 44 of them. I don't even want you to do all 44 of them. But I do want you to pick out 10 to 15 of the hardest ones and do those, because if you can do the hardest ones, the easy ones will be cakewalk. The answers are, if you scroll down, you'll see that the answers are there. So do that for homework. All right, thanks.